Okay, this is a little simulation to compare features in plants that help them not starve. And I'm going to compare those features in the context of two very different types of environments. So the environments are going to be tropical rainforest, which you're seeing here, and then Chaparral or Mediterranean climate, which is a much drier type of setting. Let's talk about tropical rainforest first. So tropical rainforest, tropical means it's in a region around the middle of the planet, near the equator, and so that means it's hot all year round. Rainforest means that, well, it gets a lot of rain, up to 100 inches of rain. So in the tropical rainforest, as we're seeing here, water is abundant. It's super abundant, and we don't really see features in special features, unusual, remarkably unusual features in plants that help them to get access to water or to conserve water. There's no real water conservation happening here in the tropical rainforest. But there are things that are in short supply. Although water is super abundant, one of the things that the water can do is, you see here, is it's washing away, it's running off as a result of this rainstorm that we're in right now. That water erodes the soil and then carries the soil with it and washes that soil away, and that soil contains mineral nutrients. So the rain tends to, and as mineral nutrients are water soluble, they dissolve in water, then the rain tends to leach excuse me, the rain tends to leach those mineral nutrients away, and that's one of the surprising limitations in the tropical rainforest, is that mineral nutrients are in short supply. And again, it's not one of those things you would think of. You think of, oh yeah, there should be plenty of nutrients, but because of the abundant rain, the rain can wash a lot of those nutrients away. There's another reason that nutrients are in short supply, and it's because in the tropical rainforest it's high density. There's just a lot of plants growing, and all of those plants are competing for limited amounts of mineral nutrients. So high competition amongst other plants also tends to explain why the soil in the tropical rainforest is nutrient poor. So that's a problem, because plants can use nutrients to build themselves, but they tend to be in short supply in the tropical rainforest. So there are some features that we see that have the result of helping these plants get more mineral nutrients. This I'm looking at here, this feature here in this tree, is it has these surface roots, these large roots that are on the surface or just below the surface of the ground. And those roots provide certain benefits in terms of helping that tree get access to more mineral nutrients. If you take a look here, you can see the ground is covered in leaves. The leaves have fallen from a whole bunch of different trees. And as it's moist and as it's warm in the tropical rainforest, then the rate of decomposition is very, very high. So you have rapid decomposition on the surface of the soil after these leaves fall. And once they're decomposed, the nutrients that are bound up in them right now, those nutrients are liberated and released into the soil right at the surface. And if you have roots that are positioned right at the surface, then they're going to have first access to those mineral nutrients. So surface roots help these trees get first access to newly recycled nutrients that are returned to the soil following the decomposition of plant material like leaves and stuff. Another thing that the surface roots can do, they can act as like little dams. So as the water is running off, they can trap that water and stop it for a time. And when that water gets stopped, as it's carrying silt and sediment, that silt and sediment that it's carrying, once the water is stopped, drops out. And so that's what you can see happening here. These are little pools of water that have been developed because the roots have stopped the runoff, and then they're collecting the silt and sediments that water was otherwise carrying away from them. So that's that silt, that muddy water that you see there, is very, very high in mineral nutrients, and so that's a really useful benefit, useful result of having shallow roots, is that they can trap that runoff water and then collect the mineral nutrients that otherwise would be leaving the area. So those large surface roots is one very useful way of coping with the shortage of mineral nutrients. Now, there's other problem here in the tropical rainforest, and that problem is getting access to the sun. If you tend to be a shorter plant, like these guys here, then you're going to be, those shorter plants are going to get shaded out by taller trees. You can see that growing tall in the tropical rainforest has real benefits. It allows the trees to get access to the sun. Where's that little dog barking? But if you're a shorter plant, like this one here, smaller plant, then it's getting access to the sun is going to be difficult, because again, the taller trees nearby are going to be shading you out. So I want to talk with you, show you an example of a lifestyle in plants that allows smaller plants to increase their access to the sun, not be blocked out so much, and also increases their access to nutrients, even though they're smaller plants. So what I'm showing here is these are plants called epiphytes. Epi means on top of, phyte refers to plant. So these are plants, and the plants I'm talking about are the plants with the large white flowers. Now, these are not true tropical rainforest, full disclosure here, these are not true tropical rainforest epiphytes, but they're the closest thing I could come up with as I'm using the Far Cry 5 arcade map editor in this simulation. So this is the closest I could come. At any rate, these are smaller plants that are living on the surface of trees. Epi means, as I said, on top of, phyte. These are plants that live on top of other plants, and so these plants are just using the tree surfaces as a place to grow. They're not parasites. They're not penetrating roots into the trees and sucking out the trees' sap. They're just plopping down on top. Now, the benefit for these smaller plants is that they are now much higher up, which means that will increase their access to direct sunlight, which again is in short supply if you're a smaller plant. So that increases their sunlight exposure. Secondly, as leaves fall down from above, epiphytes tend to have little cups, or some of those plants get trapped in the epiphyte itself, and some of those leaves get trapped in the epiphyte itself. And as those leaves get trapped and stay in the sort of the trapped on the epiphyte, they tend to decompose there. And after they decompose, the nutrients from that decomposition is now available to the epiphyte. I give an example in the chapter and also on the presentation page of a plant called a bromeliad. And bromeliads are good examples of epiphytes, and they have a real sort of a cup-like structure to them that that acts like a sort of a trapping basket that traps water and falling leaves, and so that's a good example. So in the tropical rainforest, water is super abundant, nutrients are in short supply for all plants, and then sunlight can be in short supply for smaller plants. So these are some interesting workarounds. So let's go talk about the chaparral now. So the chaparral is a very different type of ecosystem. The climate is dry. It's seasonal climate, so they have winter, spring, summer, fall, and unlike the tropical rainforest, the climate is much drier. So the pattern goes like this: in the wintertime, when it's cooler, in the chaparral, Mediterranean type of climate, you get maybe 14 inches of rain during the cool months, and in the summer there's no rain at all. So it's cool, moist winters, and then hot, dry summers. So the big problem here in the chaparral for plants is conserving water, because there isn't that much of it, and they tend to have there's a lot of evaporation during the hot summer months, especially the end of summer. So we see some features in chaparral plants that can assist in the conservation of water, and one of the features I'm trying to show here is this plant here has a sort of a low ground covering growth pattern. So the chaparral tends to be sort of like an encrusting growth, where the plants sort of spread out and cover the earth. And the benefit here is that the plant is, as it's spreading out, it's shading the ground. Okay, so it's intercepting the sun before it hits the ground, because the ground is where the moisture is. That's where the water is. So the plant's got its roots in there, in the ground. It keeps the sun off, and that reduces evaporation of soil moisture, and that can be a benefit. Now, another benefit for this sort of low ground covering growth pattern is it also can help protect the soil from the wind. So if the wind is coming and hits this plant, then it's going to be sort of diverted up and over and around the plant, and that keeps the wind away from the soil, which also tends to be, the wind is also a drying force. All right, so that's kind of cool. I wanted to talk with you about something else too. We see this a lot in chaparral plants, and that is the leaves tend to be light in color, and the lightness means that they look brighter to us because they're reflecting more sunlight. So light colored leaves absorb less sunlight because they're reflecting it, and that reduces their heat gain from the sun, that reduces their temperature gain and their evaporation. So you see light colored leaves as a way for the plants to actually avoid the sun, which is kind of, it's opposite compared to what we saw in the tropical rainforest. In the tropical rainforest, plants benefited by maximizing their exposure to the sun. But in the chaparral, plants benefit by minimizing their exposure to the sun, because the sun tends to dry them out, and there's a shortage of water in the chaparral. Also, in the chaparral, the leaves tend to be smaller, as leaves are the main site of evaporation from plants. Then as the leaves are smaller, there are fewer stomata, because the stomata are those little pores in the leaves. So if you have a smaller leaf, you have fewer pores, fewer stomata. If you have fewer stomata, then there's going to be less evaporation. So it's kind of an interesting comparison and opposites. In the tropical rainforest, plants have plenty of water, but they don't have enough nutrients and sun. In the chaparral, they have too much sun and not enough water. Let's talk about nutrients. So in the tropical rainforest, nutrients recycle rapidly because it's warm and it's moist. In the chaparral, because it's dry, although it's warm but it's dry, then nutrients aren't recycled rapidly in the chaparral. And so that could be a problem, as there could be a shortage of nutrients because of slower decomposition rates because of the dryness. But hey, little guy, little bunny. So in the Chaparral, we see there's a pattern that develops where there are wildfires. And what the wildfires do, although they are destructive, what they do is that they burn, as they burn the plants, all of the nutrients that were inside the plant then get completely burned and returned to the soil as ash. So wildfires tend to be an effective way to recycle nutrients in the chaparral, destructive as they might be. So that kind of gives you a good comparison about how plants don't starve, and it depends largely on the climate and the physical circumstances of their environmental surroundings, which sort of explains why we see different mixes of features in plants that live in the tropical rainforest versus plants that live in the chaparral.